Me oleme külla kutsunud Janne Peltoneni, kes töötab VTT-s. Next speaker is Janne Peltonen, Building Automation in Finland. The floor is yours.
Okay, thank you very much. So, good afternoon, and my name is Janne Peltonen, and I come from the VTT Technical Research Center of Finland. And today I will talk to you about this kind of one case project, which is cooperation with VTT and Samsung CFT, and it's related to this smart city theme very closely. And we call it Building Together a World-Class Eco-Campus. So first of all, some motivation. So why are we doing this? So as we know, EU countries committed strongly to cut the CO2 emissions. And then also the buildings have a key role in climate change combat. Buildings use about 40% of energy and are the biggest source of greenhouse gases. And also buildings have key role in climate change combat. Major challenge is in the existing building stock, as we know that the building stock renewal rate is only about a little bit over 1% per year. But also the biggest potential is in the buildings. So some background, why are we doing this in our Eco-Campus Otaniemi area? So it's important that we have environmental monitoring for the campus area. We need monitoring, we need key performance indicators, and we need to have feedback from the users of this green campus area. So the continuous assessment and improvement of our own activities is very important. And then real-time feedback to various stakeholders. We need feedback for and from users, owners, different kind of operators, and how to involve different users. So the target is to have awareness, motivation, and real actions. So then shortly about the project facts. So this is KMEC VTT Eco-Campus Energy Grid project. It started 2012 and it will last until next summer. And this is a direct customer cooperation between VTT and Samsung CFT. And the main objectives of this project is to save energy and improve energy efficiency in Otaniemi Eco-Campus area. And mainly we concentrate on electricity and district heat. And also we think about further to the future that how to connect macro energy grid as a microgrid for energy business. And the main idea in this project is to try to pilot how to use smart devices and how to enable new ICT technology in the building and real estate industry sector. And of course we are thinking about what kind of new ICT-based market openings can be done in this kind of district and community level. So then shortly about the KMEC Korea Microenergy Grid Program. So KMEC is a Korea's future flagship program in energy industry. And the administrator is Korean Ministry of Knowledge Economy, and the principal leader is Samsung CFT, and there are about 60 total Korean companies involved in this consortium, SME companies, large companies, research centers, universities, and VTT is from Europe, and also some partners from North America. And the budget is almost $100 million, and mainly we are doing cooperation with Samsung CFT, Korea Telecom, and then Nara Controls. Nara Controls is a building automation company from Korea. So then the objectives of KMEC is to develop advanced energy solutions for energy saving and mainly enabling different kinds of ICT technology to different areas. And the idea is that the technology will be validated by solutions through test beds, and the main objective also is to improve building energy efficiency by 30% by active systems. So in the KMEC, they developed this kind of total energy solution packages for different kind of district level solutions for energy in the industry, and also in the building and real estate sector we have this autonomy campus pilot. And the idea is that, for example, if a Samsung mobile phone manufacturer owns a large district area with its industry buildings, all the savings that you can gain from that area, it goes directly to the bottom line of this company's profits. So there's the potential. And also the KMEC concept, it's about integration of electric power, heat, gas and water with IT infrastructure, and in the core of this KMEC is this kind of smart IT platform. So then about what's our role in this KMEC. So BTT offers this Autonomy Eco-Campus area as an overseas demonstration site, and mainly to activities they are piloting and demonstration and like product development kind of activities with different companies. And so first of all, building together Eco-Campus 2030, our overall project mission is to increase energy efficiency and enabling new ICT technologies, ICT-based business models, and also we have this kind of concrete target that we want to save 15% of delivered energy, including electricity and district heat. And this is some kind of evidence that we will show in some buildings. And from the autonomy area, there are all the biggest building owners are involved in this project, so they provide their building stock to our research use. So there's Senate Properties, Aalto University Properties Ltd, and also this student housing sector. Also there's City of Espoo, and then we are also starting cooperation between this Tekes-funded RYM Ltd R&D Center. And then here you can see the area that's included in this project. So there are 100 pilot buildings included as a high-level pilot in this project. And then there is 10 selected detailed pilot buildings for detailed level piloting activities. And at the moment we have collected about 10,000, a little bit over 10,000 data points from this campus area. And also there's this, we use this as a living lab for users, and there are a lot of active students that are involved also to this project. So how we started this work, before we made this cooperation with this Korean consortium, we got together with all the building owners of the Autonomy Eco-Campus area, and we developed this kind of Vision 2030 for this campus area. And for us it's to realize net zero energy campus for world-class demonstration and education for sustainable communities. And there are 4 strategic pillars that we made here. First is the user orientation. It's about the energy awareness of the users. Second, energy efficiency. net zero energy and near zero CO2 solutions. And third, building integrated and district multi-energy solutions as energy hubs. And then finally, we also deal with the future business models. And this project, we just take the first steps toward this Vision 2030. This world will not be ready after this project, but hopefully we will have this basis for new development activities. So then here's one picture of this technological side of our PTT Smart Eco Campus. And in the core of this is the ICT platform that we have developed here. And so we call it this kind of service platform or total operation center. So the idea is that we collect all the data from this campus area to this service platform. And then this is kind of you could call this service platform or service operation system. And the idea is that we analyze the data, we develop these different kind of key performance indicators, and then we develop reporting solutions with different kind of user interfaces, like mobile user interfaces, tablets, and so on. And the targets here are the different user groups. For example, the students and the other users of the buildings, and then operation and maintenance staff, they need their own services to handle their daily operations, and then other expert users that will be here. And then this in this project, this total operation center, this is Korea Telecom's technology. So they have installed one server in our facility, and they can also operate it from Seoul premises. Okay, then about so at the moment we have the project. It's not finished yet. So we have succeeded to build the ICT infrastructure, and we have huge amount of information available for analysis. And for example, we have from almost from 200 energy meters, this kind of hourly energy information available. And then we have installed these kind of environmental sensors, over 1,000 measurement points to our pilot buildings. And then we have smart meter or sub-metering systems, about 50 pieces, Korean technology and also technology from Finland. And then also we have in 2 case buildings this kind of large building automation integration done. So huge amount of information available. Then about the data, here are some examples of the smart sensors that we have installed. Plug load sensors for the electric loads, indoor air sensors to get the temperature, humidity, CO2, and lighting levels. And these are like wireless sensors that are Zigbee operated, and also every sensor you can. We are developing different kind of user interface solutions for example, office building users that in every office room you can access to your temperature information and so on. Then the AMI sub-metering systems we have installed. Here's also an example of a Korean sub-metering system that all the information is available real time in a tablet or mobile user interface. And here's one example of mobile interface. This is from one pilot apartment building that we installed full of sensors that in every apartment the user can access his apartment's energy information, and also there are this wireless indoor environment sensor information available. So this is kind of a low-cost new business concepts that they are now at the moment marketing, for example, in South Korea, and they sell it to apartment buildings. And then here is a comparison of a solution from Finland, a company called MX Electrics. They have their smart metering solution, which uses an algorithm that can detect the electric usage of different electric loads, and the user can also access it by mobile applications. And we got quite a nice results from these apartments for the electric energy savings. Then here's one example of the building automation integration. We have this new research hotel that was built in 2012. So we have their Fidelix building automation system, and at the moment we monitor all the building automation data points real time to our energy management system. So this is a group energy management system from Nara Controls, and the idea is that we can go further in the analysis functionality than a traditional building automation system can do. For example, data analysis and optimal control. And also we have developed interfaces with the electric market. So we are doing this kind of test that when the electric price, hourly price varies, so then we can give here control signals that which are the loads that could be shut down or driven in smaller power, for example, cooling. Okay, then here's some example of our total operating center. So here's one picture of the Korean Seoul. So this is Korea Telecom's operation center, and here you can access, for example, VTT site, and here you can see that we have about, in this version, 160 total meters included, and you can see all the information for the measurement points. And then the idea is that we develop this kind of Google Map-based user interfaces that we can do different kind of benchmarking functionalities for all of our buildings in this Otaniemi site. And also we developed this kind of key performance indicators for the operation and maintenance staff based on this total operation center. And then also there is capabilities of do different kind of analysis that we can deliver information to mobile user interfaces also. Then shortly about what we have learned about this project, about the future insights. So we see that this kind of smart operation and maintenance will be in the future very important, and the target is to lead daily operations by information. So I would say that converting big data to information is the most important thing in the future, and so leading with information, those partners or companies who can do that will succeed in the future, I think so. And also developing and piloting continuous monitoring and reporting methods and models for efficient maintenance and operations. So remotely operated buildings is very important. And also there are big challenges. So I would say that this technology support, it's only half of the energy saving, and the other half is the end users and other stakeholders, that how you motivate the users of the buildings to use the energy wisely. And I think that when we give this kind of new technology to the users, they will be more energy awareness, and the behavior will change if we think about the next 5 years or 10 years. And then also we think that there is this kind of a new business opportunity for this kind of monitoring-based commissioning service operator. And this monitoring-based commissioning refers to the practice of continuously tracking and analyzing energy and other key performance data. So measurements of energy use, diagnose problems, account for savings, help ensure that savings persist over time. And also the indoor air issues are very important, that you have a high productivity at the workplace. And as we all know, the people make most of the costs in companies. And here's a hypothetical calculation of business potential in Finland per year for the whole existing building stock. If we think that energy consumption of buildings equals 10 million euros, so very conservatively 2.5% energy saving rate equals 250 million euros, and if you put 50-50, the profit sharing with building owner means about 125 million euros revenue for the MPCX service operator. So I think there could be a business potential in the future. Okay, thanks.